projectile strikes a plastic sheet and the speed goes 150 meters per second to 50. And we want to know which represents the best momentum change for the projectile. So the change clearly is a negative change, so we're really stuck between choices B and D. And when I really look at the size of this change, it's not a small change like B would reflect. It's really quite a drastic change, is why I would choose D. For 42. You know what? We're going to skip 42 and 43. These are a bit much for you right now. We're going to get to these next year. Now, repeated measurement of a quantity can only reduce the effect of a random error. If there's a systematic error, that's something built in accidentally, unintentionally built into the design of your experiment, so to speak. So you're going to keep measuring it each time, so you never eliminate it. Whereas a random error, you get better sample size, sample space, and so repeated measurements reduce random errors. As the angle theta increases from 0 to 90, how do the x and y components vary? Another way to say this is if you have a unit circle and your radius goes from the x to the y-axis, what happens? Your y component increases. Look at this. Like if you get it perfectly vertical, y is as big as it's going to get, and x is really tiny. So we need x component to decrease, and we need y component to increase. So that leaves us choice C. All right, moving on to question number 46. So we've got two stones, one straight up, one straight down at the same initial speed, but they both hit the ground. This is an interesting thing. So one of the interesting things about throwing something up in the air, so if I throw something up at a speed v, it actually returns back down with the same speed. So what that tells us is it's kind of like P may take a longer time to hit the ground. We're not interested in time, though. We're interested in just the speed. So they're going to hit the ground with the same speed, since P effectively turns into what Q does at a later time. And here, a ball is thrown vertically upward if air resistance is negligible. Which one of the diagrams below is the correct free body diagram of the force? Once again, it's that same idea that when you throw an object into the air, on its way up and on its way down, and even at the very tippy top when it's stopped for just that split second, no matter what's going on with it, the downward force is the only force that acts. And let's be clear that that downward force is the very weight of the ball, or if you prefer, the force of gravity. Number 48. All right, so we have a car that accelerates from rest, travels at constant velocity, then decelerates to stop. We want the graph of displacement versus time. It's very tempting. I'm going to tell you, this answer here is wrong. This is velocity versus time, so let's be clear. When we start off, we're going to accelerate, then we continue at a steady pace, and then we're going to slow down to stop. So we actually end up getting choice C. Let's see, next one. An iron cannonball projected horizontally from a cliff. We're going to neglect air resistance. Now, if you replace this with a more massive object, but you can ignore air resistance, it's going to land in the same place. When you ignore air resistance, don't let the heaviness or the lightness of the object fool you. Okay? And this is a constant thing. This is similar to a problem we did with the wood and the iron ball being dropped. So, again, it's just that idea that when things fall and there's no air resistance, you don't have to worry about mass. Or rather, mass isn't a factor in the rate of falling. Now, once again, the two-box problem. Two bodies, P and Q, connected by a light cord. We wrote down some facts for these that I'll refer you to. I think it was in the first or second video. Let's just recall. The mass of P is greater than Q. Okay? Even so, The force accelerating P is going to be less than F, but not 0. Okay, because this F has to pull both boxes, but the force on P right here only has to pull box P. So that's questions 41 through 50. As you can tell, the pace is picking up just a little bit simply because we're starting to see some problems. We're kind of seeing some themes and problems, ideas that come up again and again.